Hello students, in this video we are going to see about linear integrated circuits. What is linear integrated circuits, applications, advantages, disadvantages, block diagram, internal circuit diagram and all. First of all, we see introduction to linear integrated circuits, next basic information about op-amps, third block diagram of an op-amp, fourth one internal circuit diagram of IC741 op-amp. First let us see what is linear integrated circuits. Linear means input and output varies linearly. If input varies means output varies linearly. Integrated circuit means it is a miniature low-cost electronic circuit consisting of active and passive components fabricated together on a single crystal of silicon. That is, it is an electronic circuit which consists of active and passive components such as transistor, resistor, capacitor, like that. All are fabricated on a single crystal of silicon chip. Then what are all the applications of IC is day-to-day life we are daily watch the applications of IC. It can be used in computer industry, toys, automobile industry, televisions, like that, home appliances, communications and control systems and all electronic gauges, etc. The main disadvantages of discrete circuits are why we are going integrated circuits. Before integrated circuits, discrete circuits are used. The main disadvantages of discrete circuits are assembling and wiring of all individual discrete components take more time and occupies a larger space required. Actually, we have to connect the discrete components by using wiring or soldering process. It may take more time. To overcome this problem, integrated circuits are developed. The main advantages of integrated circuits over discrete circuits are it is a small size, cost reduction, less cost, less weight and increased operating speed, and it consumes less power. Around 20,000 electronic components can be incorporated, that is, can be fabricated in a single square IC chip. So that integrated circuit has many disadvantages over discrete circuits. The main disadvantages of an integrated circuits are if you constructed all the components in a single chip, that is electronic circuits in a single chip, it is not possible to modify the parameters and which an integrated circuit will operate. When any one of the component or IC gets damaged, the whole IC has to be replaced by new one. The components cannot be replaced. The whole IC has to be replaced. This is the main disadvantages of an integrated circuits. And for higher value of capacitance, that is greater than 30 microfarad, we should have to connect a discrete component externally. A greater than 30 picofarad capacitor value cannot be fabricated in an integrated chip. These are all the disadvantages of linear integrated circuit. And the types of ICs, that is classifications of IC, can be categorized based on function. It can be classified as digital IC and linear IC. Digital IC deals with ones and zeros. Linear IC deals with analog signals. The examples for linear IC is IC741, IC565 and all. The digital ICs, familiar digital ICs are AND gate, OR gate, XOR gate, like that. And based on fabrication, ICs can be classified as monolithic IC and hybrid IC. And based on number of components integrated on the same chip, the ICs can be classified as small scale integration, medium scale integration, large scale integration, up to 3D integrated circuit. The latest version is system on chip and 3D IC chip. In small scale integration, less than 100 transistors can be fabricated in a single chip. It was developed in 1963, and in medium scale 100 to 300 transistors can be fabricated It was developed in 1970 like that. Now gigascale integrations are in current. In that greater than 1 million transistors can be fabricated. These are all the images of analog ICs and digital ICs, that is general ICs images. These are all the discrete components, the discrete circuits examples. These are all the separate components: diode, resistor, transistor, capacitor, IC. We have to connect it in PCB or breadboard. We have to wiring that, or we have to soldering these components for interconnection. These are all the examples for discrete circuits. It will take more time, and large circuits cannot be fabricated easily. It will take more time. Troubleshooting are very long process. So overcome this discrete circuit disadvantages, we are going to integrated circuit. These are all the integrated circuit examples. In this circuit, in this chip, all active components and passive components are fabricated in inbuilt. It was available in three categories. One is dual inline package. This one is dual inline package, and another one is plastic quad flat package. Another one is flip chip board grid array package. This one is plastic package. This one is flip chip board grid array package. This one is dual inline package. That is pins are arranged in a double line evenly, so it is called as dual inline package. The following is the definition for integrated circuit versus discrete circuit. An integrated circuit is an IC chip which consists of resistors, capacitors and transistors all integrated internally in IC chip, which will available as a silicon chip. It was developed by Jack Kilby in 1950. In discrete circuit can be constructed separately by connecting circuit board by using soldering or PCB board. In that, transistors and resistors like that, all components are interconnected by using wires or soldering. These images are the difference between discrete circuits and integrated circuits. This one is discrete circuits connection. This one is integrated circuits connection. IC chip are all in single board. The separate components are soldered in single PCB board. This one is discrete. This one is integrated circuit. Now we are going to a linear integrated circuit. In linear integrated circuit, opamp is the main one familiar example for an analog linear integrated IC chip. Let us see what is an opamp. It is a direct coupled high gain amplifier consisting of one or more differential amplifiers followed by a level translator and an output stage. Here the active components are transistors, FET are fabricated, and passive components are resistors, capacitors, etc. By properly selecting the external components with this IC, it can be performed variety of mathematical operations. So this amplifier is called as operational amplifier. Operation means mathematical operations this IC can do, like calculator. It can do mathematical operations such as addition, subtraction, multiplication, integration, differentiation, etc. Many more applications. It is a type of linear IC. Opamp IC number is 741. IC 741 is operational amplifier IC number. It will be available in market in three packages. One is dual inline package, another one is metal can package, another one is ceramic flat package. In dual inline package, pins are evenly distributed, 8 pins. In metal can package, metal piece is topper. Below that, 8 pins are leads are available. In flat package, IC is looked like flat model. Here 4 pins and here 4 pins are placed. Totally 8 pins. So this IC has 8 pins. These are all the another example for models. Another image is model. This one is flat package. This one is dual inline package. This one is metal can. This piece is like that, metal can. This one is flat, so it is called as flat package. Why it is called as dual inline means the IC pins are evenly distributed in double side, left side and right side. So it is called as dual inline package. The circuit symbol for of an IC74 is shown in left hand side and pin configuration is shown in right hand side. This IC74 has 8 pins and only 5 pins are active. Second pin is inverting input terminal and third pin is non-inverting input terminal. Sixth pin is output terminal. Seventh pin is positive supply voltage and fourth pin is negative supply voltage. Pin configuration has 8 pins. One is offset null, second one is inverting input terminal, third one is non-inverting terminal, fourth one is negative supply, that is minus 15 volts should be given. Fifth pin is offset null, sixth pin is output, that is output is taken across this pin. Input is connected between either 2 or 3 or between 2 and 3 pins. Seventh pin is positive power supply, plus 15 volts should be given, and 8th pin is not connected. This is an 8-pin IC. We have to know the pin details of all 8 pins. Out of all 8 pins, 5 pins are mainly active pins. That is second, third, 7, 4, 6. 2 and 3 are inputs. 6 is output. Inputs are connected between these terminals. Output is taken across this terminal. And supply voltage should be given to 7 and 4. Positive supply and negative supply must be given. The range is plus 15 and minus 15 volts. This is the symbol of opamp 741, and applications of opamp is it can be used in calculators and voltage to current converter, analog to digital converter, digital to analog converter, etc. It can be used as filters, instrumentation amplifier and mathematical operations such as adder, subtractor, logarithmic amplifier, differentiator, integrator, etc. This is the main block diagram of an opamp. It has in internal IC741, it consists of 4 stages. One is input stage, second one is intermediate stage, third one is buffer level shifting stage, buffer and level shifting stage, fourth one is output stage. In input stage, dual input balance output differential amplifier circuit is constructed, worked as input stage. In intermediate stage, dual input unbalanced output differential amplifier is used. In third stage, emitter follower can be used as buffer using constant current source. And fourth stage is complementary symmetry push-pull amplifier can be used as fourth stage. The input stage has dual input balanced output differential amplifier is inbuilt. Why it is inbuilt means this differential amplifier provides most of the voltage gain. The dual input balance output differential amplifier provides most of the voltage gain to the opamp IC741, and additional voltage gain is given by intermediate stage. The intermediate stage is nothing but dual input unbalanced output differential amplifier, that is dual input balanced output. Here dual input unbalanced, 2 inputs and a single output, so it is called as dual input unbalanced. Here 2 inputs and 2 outputs, so it is called as dual input balanced output differential amplifier. In input stage, differential amplifier is present. In intermediate stage also differential amplifier is present. In first stage, most of the voltage gain is provided. If additional voltage gain are provided by the intermediate stage. In this stage, dual input balanced output differential amplifier used. In intermediate stage, dual input unbalanced output, that is single dual input single output, so it is called as dual input unbalanced. Here 2 inputs and 2 outputs, so it is called as dual input balanced output differential amplifier. And third stage is mainly used for buffer and level shifting stage. Here there is no coupling between one stage to other stage, so all DC signals are amplified by all the stages. So DC levels may drive all DC levels will amplify, will be high DC voltage level. It may drive the transistor into saturation and output becomes clipping and distorted. So it is necessary to bring such a high DC voltage level to 0 volts with respect to ground. So we are using, so here buffer and level shifting stage is used to, buffer is used to prevent the saturation, and level shifting stage, it brings the high DC level voltage level to 0 volts. High DC voltage level is shifted to 0 voltage level. And fourth stage is output stage. Here complementary push-pull amplifier is used. It meets all the requirements like low output impedance, large AC output voltage swing, and high current sourcing and sync capability. All parameters are provided by last stage. The final stage is the provides output of the opamp. Push-pull complementary amplifier circuit is integrated in the fourth stage. These are all the explanations about block diagram of an opamp. This is the overall block diagram. This is symbol of opamp IC741. In this symbol, internally in the IC chip, these are all the 4 stages: input stage, intermediate stage, level shifting stage, and output stage. In each stage, the following circuits are integrated in IC. Therefore, 4 electronic circuits are integrated in IC74, integrated in the integrated IC chip IC741. This is the internal circuit diagram of an opamp. This is the block diagram of an opamp. And the block diagram has separate electronic circuits. The electronic circuits are shown here. First stage, second stage, third stage, and final stage. So totally how many transistors are inbuilt? 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 transistors and resistors are inbuilt in IC. So this opamp IC has come under small scale integration. In previous slides, we have seen based on components, the IC chip can be classified as small scale integration, medium scale integration, like that. So this IC741 opamp comes under less than 100 transistors, that is 20 transistors are inbuilt, just now we have seen. So it comes under small scale integration and monolithic IC, and another is based on function. It can be functioned as linear IC, linear monolithic small scale integration IC, we can tell. So this is the final block diagram of an opamp, internal circuit diagram of an opamp. Thank you, students. Let you play the video and study 2 or 3 times. The concept will be basic concepts and block diagram applications, internal circuit diagram will be clearly understood by you. Thank you, students.